This video is on the objective graph a circle or a line from a polar equation. Alright, and this is unprecedented here. This is the fourth video I'm doing because in the first video on this objective I graphed something called a rose. The second video I graphed a line going through the origin. The third video was a line not through the origin, a horizontal line. And there's other lines. I didn't cover everything, but I haven't seen any circles yet. So I wanted to go over one of the questions where your graph is going to be a circle. So here's an example here. Now this is not part of my preview, so you're not seeing the more instruction or anything like that. But in your, of course, in your assignment, you'll see more instruction on the bottom. Click on that if you want to see the notes and videos and examples that they have for you, and hopefully those help you. So they're asking us here to graph this polar equation right on the polar grid. R equals 3 times the sine of theta. Now you're already seeing the answer here, right? They filled it in for me, but this is, let's see how this comes up as a circle. So we have R equals 3 times the sine of theta. All right. So again, I'll make a little polar grid, very rough. So here's your polar axis, horizontal. The vertical axis really means nothing, it just breaks up the quadrants. And then we'll have a circle of radius 1, a circle of radius 2, a circle of radius 3, and really that's all I'm going to need is, because remember the value of the sine of theta, the largest that's going to get is 1, and the smallest it would get is -1, and then multiplying by 3, means the largest any radius is going to get, any r is going to get is 3, and the smallest it'll get is -3. Alright, so I got -1 on the polar, -2 on the polar, and -3 on the polar. And I'll draw those little circles in this, make again a rough grid. And circle with a radius of 1. This is awful already. Sorry. Alright, and then a circle with a radius of 2. And a circle with a radius of 3 that we're traveling around. Okay. Alright, now, like I've done in some other videos, before I get to graphing this, now you could make a little table with values of r and values of theta. You plug in different values of theta and see what the value of r is, and then you plot that point, and you keep plotting a bunch of points that way. What I'm going to look at is the XY version. Right, the XY version. Now this doesn't mean it's rectangular, okay? I'm not converting this to its rectangular form. I'm just changing r to y and theta to x. Okay, I'm looking at the graph of y equals 3 sine x. The way we were used to graphing things, x-axis, y-axis, and remember how we graphed trigonometric functions in the past. So remember this has a period of 2 pi, no phase shift. Alright, so I'm going from 0 to 2 pi here. I'll cut this into quarters. So every pi over 2, and plug these in. The highest it's getting is 3, the lowest it's getting is -3, and sine of 0 is 0, sine of pi over 2 is 1, but then times 3 is 3, and then 0, and then -3. Right, I'm not going to explain how this graph was made. You should know how to graph your trigonometric functions by now, right? And you got a sine wave. All right, there's one cycle, and I'm going from, remember x is representing theta here. So when I go 0 to 2 pi, that's like going once around on the polar grid. Theta equals 0 to theta equals 2 pi, and that'll give me the entire graph that I'm looking for. Okay. So now, if I look at the first part of this from here to here. That's from theta equals 0 to theta equals pi over 2. Theta equals 0 is, this polar, representing like the positive polar axis here. Theta equals pi over 2 would be, going to the positive vertical axis. And if you look at the value of the y coordinates, I'm going from y equals 0 to y equals 3. Well, that's what's going to happen to the values of r here. So r equals 0 means you're at the pole. Right? That's corresponding to this point. R equals 3 means, you're 3, I go 3 pi over 2. Right? That would be this point here. So 3 pi over 2, I plot 3 pi over 2. Now you got a bunch of other points in here where you see that as I move through this first quadrant, the values of r are, going from 3 all the way 0 all the way out to 3. They're doing it very quickly in the beginning. It's pretty steep, and then it slows down. So what's going to happen here is something like this. The value of r, shoots out quickly and then slows down and eventually gets out to where you have a radius of 3. All right, so really what you're getting here is like a semicircle. All right, and again, it takes like kind of just practice to see what's happening there. Now, if you wanted to plot some more exact points and plot, be more exact and get actual points up here, be my guest. But I'm just making rough sketches, right? And then I'm going to go to a calculator on a website and show you a much prettier picture. All right, so that's from 0 to pi over 2. Now, what about from pi over 2 to pi? So pi over 2 to pi, I'm over here in quadrant 2. The values of r go from 3, so I'm at this point, to 0. So I go down to 0 pi, right? 0 for r, pi for theta. So I'm coming right back down to the origin, right, when r is 0, and it's basically the other half of this semicircle, right? The values of r go from 3 down to 0. And they decrease slowly and then decrease more rapidly. And you get now this isn't a perfect circle or anything, but it is a circle. And this is again 3. And this is, in the center would be at 3 halves and all that, and but it is a circle. And then the rest of it, okay, if you were to go and say, hey, well, what about this rest of this graph? If I go from pi to 3 pi over 2, look at this piece of the graph. Well, from pi to 3 pi over 2, my picture is I'm in quadrant 3, but, see how the values of r, the y coordinates, are negative. So if I'm in quadrant 3, but the r values are negative, I'll be plotting points up in quadrant 1 on the opposite side of the circle, right? Because r's are negative. And you'd basically get this half again. Right? You'd just be tracing over the graph one more time. Right? Same thing here from 3 pi over 2 to 2 pi, 3 pi over 2 to 2 pi. I'm in quadrant 4. But again, the values of r are negative, so I go the opposite. I'd be in quadrant 2 and be plotting, basically tracing out this part of the graph again. So just going through this whole picture here and translating it to the polar grid traces out this circle twice. But the graph is a circle. All right. Now, let's see that actually happening. Let's go to, this is that desmos.com, right? Here's r equals 3 times the sine of theta. And there's a circle, right, with the point 0, 0 at the bottom of it, right, the point 0, 3 at the top. Right, there's 0, 3. Oops, it is zoomed in. Right. But yeah, so there's your circle. Now, another thing you could have tried here, right, if you're still uncomfortable graphing with r's and thetas, we could have taken our equation, and you can also try, right, or you can try, converting to rectangular, right, as we've done in other videos in previous objectives. Converting to the rectangular version of this equation. So if I just do this, if I take and I multiply both sides by r, that gives me r squared equals 3 times r sine theta. And remember, r squared is x squared plus y squared in rectangular. And then r sine theta is y. And this is the equation of a circle. That same circle in rectangular, and let me show you this, right? Take away the 3y, so we have x squared plus y squared minus 3y equals 0. Complete the square on the y's here. We would add 9/4 to both sides. And look, we have x squared plus the quantity y minus 3/2 squared equals 9/4. This is a circle with a center, the center at point 0, 3/2, and a radius of the square root of 9/4, so also 3/2. And that's exactly this picture. See, the center is at 0, 3/2, and the radius is 3/2, right? The distance from this point to that point is 3/2, the distance from this point to that point is 3/2, to any point would be 3/2. It's exactly the same picture. All right. And again, let me show you. I'll just write this equation up. The x squared plus y squared equals 3y. I'll put that up on my Desmos website. All right, change this to polar coordinates. X squared plus y squared equals 3y. And look, it's the same exact equation. They are plotting the same curve. So if you want, I mean, you can try. Oh, I don't know. I'm going back here. If you want, you can graph this like usual. Graph this like any other polar equation. Plug in values of theta, get values of r, plot points, like I've been doing, or try changing it to its rectangular version and graph that, and they'll have the same graph. Right? And that's this first graph right here. You see that circle above the x-axis here, above the horizontal axis. Okay. And then they have their explanation down here. Blah blah. Blah. Cool. So hopefully, watching me do this several times now for several different kinds of graphs. Looking at the more instruction when you feel like it, when you feel you need to. Go to that. I'm telling you, go to Desmos.com, play around with that. You're going to see some cool stuff in polar and rectangular, and see the relationships between them, I'm hoping. And also, don't forget to read the answer explanations when you're done. See how they did things. Maybe you can learn something from that. I'm just hoping all this stuff put together, help you out immensely when you're working on this on your own. And thank you very much for watching.